If first off, you could all go to Mentimeter.
Will do.
I have some questions first to see how much everybody out there already knows about paleontology. The first question up there asks, which one of these is an actual dinosaur? The options up there are Dimetrodon, Megalodon, and Pterodactyl, and then none of them or all of them. Now, the correct answer to this one would be none of them. None of them are actually classified as a true dinosaur. Although they are ancient creatures, none of them are a real dinosaur.
Wow.
Now, which one of these creatures in the next question is related to dinosaurs the closest? Reptiles, fish, amphibians, or birds? The answer to this question is birds. This one is, what is the actual size of a velociraptor? Size of a human, size of a deer, or the size of a turkey?
Which one's the velociraptor?
The ones from Jurassic Park.
Oh, yeah.
The ones that were like in groups?
Yeah.
The ones that are like
Well, the correct answer to this one is they are the size of a turkey. And then on to the last question. Do Dilophosauruses spit venom in your life? Now, these guys are the ones that, if you remember, they killed Nedry in the first film. The answer to this is false. That is just something that the creators of Jurassic Park made up. Now, the first question some of you probably don't know is, what even is paleontology? Now, paleontology is the study of ancient life that used to live on this earth millions of years ago. I know some of you are also thinking, why would this guy in our class pick paleontology to even do a project on? Well, it is simple. You get to discover the hidden secrets of Earth's past. We have already discovered so many amazing creatures, such as the Tyrannosaurus rex, the Dilophosaurus, Smilodon, Dunkleosteus, and the Spinosaurus. My proposal is to make paleontology more accessible to the classroom so that people like me who are interested in this type of field are actually capable of learning about it and getting more involved in it in like high school rather than just waiting until college. Now currently, my idea is the 3D print fossils to make them more accessible to the classrooms. We use the engineering aspects of this by, once you dig up the fossil, you take a scan of it, it converts into a 3D model, and then you plug that or put it in to a 3D printer, and it 3D prints a 100% replica of the fossil. Now let me introduce you to one of my good friends, the Pteranodon. It is a toothed whale. It is a toothed whale from the Paleogene period, about 34 to 28 million years ago. Now the College of Charleston, I emailed them and asked them some questions. They have a skull of this that is 1 meter long, and they would love to be able to actually 3D print it to make it more accessible to classrooms. Now imagine if you were capable of taking these fossils in the classrooms. People would be able to actually get up close and personal with these fossils, so they can learn from them more and they can view them in every single detail. And it makes it a lot easier for actual paleontologists as well. They don't have to risk damaging the fossil when excavating it. They can just scan it in the rock and just look at the 3D print. Now, if I can introduce you to my two friends on the side screen, the one in the top right, that is a claw fossil from the dinosaur Eotyrannus. It means dawn tyrant, and it is from the early Cretaceous, approximately 130 million years ago in the UK. And then if you look at the one on the left, that is from a neovenator. It means new hunter, and it also is from the early Cretaceous, 130 million to 125 million years ago, again in the UK. Now, with the help of the Kate Center, I was able to actually 3D print these replicas, although the one on the left of the neovenator, it did have some issues when 3D printing because it, for some reason, slid to the side a bit. Either way, it still is like an exact replica of what the fossils I downloaded looked like. It has every little edge, curve, and indent, or anything that chipped away from the fossil that the actual one had. Although it is not that useful, just small claw fossils, because you cannot get much information from them, huge actual skull fossils would be useful. The skulls sometimes can be as large as this desk right here, and are going to be really heavy and really fragile. Now, if we are able to 3D print a replica of that, we are able to get all the data on that skull right then and there. We are able to find out from skulls like what it used to prey on, what it got hunted by, and basically if it fought for territory, because we can examine any teeth that are lodged into the skulls. Now, Ralph Waldo Emerson once said, to be great is to be misunderstood. Now that what makes paleontology so unique. It is, these creatures are misunderstood by so many people and are not even considered. Most people just go to your regular old museum, look at it, be like, hey, yeah, it's cool, it's a fossil. Yeah. Then they walk away and continue on their day, maybe take a picture with it, they'll just like, be like, oh yeah, I remember that. Now, Transcendentalism says to remain unique and separate. Paleontology is not that popular of a field to go into, so for those individuals who want to go into such a unique field, I want them to be able to actually do that instead of being forced to go into something they don't want to do just because it's such a hard field to get into. Now, everything on the past of our Earth is a mystery, and paleontology, Transcendentalism talks about the mystery of nature, we will fully never actually complete the puzzle that is paleontology, for the fact that not every fossil is actually preserved in there. So there's going to be thousands of species that there's not a single fossil actually out there of, and including with the fact that we can't excavate all the land on Earth. For all we know, there could be the next big find fossil literally just underneath this school, but because you can't really get the permits and such to start excavating underneath this school, we'll never know. Although we can learn from these creatures once used to thrive in the millions, like millions of years ago, but they all went extinct to environmental factors that they were not capable of adapting to. And this could eventually happen to us if we don't adapt quickly enough due to what we are causing to happen to the Earth. Now, some examples I have are the trilobite. It means 3 lobes, and it is lived during the early Cambrian period to the late Permian, 521 to 251.9 million years ago. They truly thrived during the Cambrian, but ever since the Cambrian ended, they were on a steep decline down into extinction. And they finally bit the dust during the Permian-Triassic extinction, which is also called the Great Dying. It is one of the most largest extinctions to happen on Earth, where more than 90% of all species died off, and most aquatic species died off as well. And due to this, there was a great acidification of the ocean, and these creatures rely on an exoskeleton to protect them. And due to the acidification of the ocean, there began to be less or more carbon dioxide in the water, which made it incapable for them to actually produce their exoskeletons to protect them. So either they died off due to the acidification, it being too acidic and it literally killing them that way, or the fact that they were not able to produce exoskeletons to protect them from predators. And this is very similar to how we are dumping dozens and dozens of waste into our ocean. And it is causing a large amount of acidification that it could lead to some major problems for us with our water beginning to get more acidic and more acidic. Arthropleura was a giant species of arthropod that lived in the Carboniferous period 315 to 299 million years ago. It means jointed ribs, and this was the time period where basically all the coal and oil comes from, due to there being large amounts of swamp area around. All that coal is possibly from creatures such as this. Now, this creature lived in North America, obviously during the Carboniferous period, and during the extinction event in this period, there began to be less and less oxygen available in the atmosphere. Now, bugs like this, they require oxygen to help them get so big. And when the oxygen decreased, they were not capable of sustaining this body. So they either died off or they had to shrink down, which caused them to go extinct because these creatures were not capable of adapting as quickly. And this is similar to how we are putting so much gases like CO2 into our atmosphere, where we are going to be reducing the oxygen in there. That is going to be polluting the air and could possibly lead to similar problems for us as well. Now finally, I have the Austroraptor. That was a species of raptor that lived in South America. Its name means southern thief, and it lived in the late Cretaceous period, 70 million years ago. Now, it specialized in eating fish, but it could hunt for meat if it was required. But after the Cretaceous Paleogene extinction, which we all know was the asteroid, a lot of the air and water was polluted, which obviously caused the fish's food source to get killed off, which would eventually lead to the fish dying, and eventually these wonderful creatures died off as well. This is similar to us in real life. We are causing the pollution of our water and air that is slowly killing off species. And with less food for us, that could lead to major disasters. And then my works item. Now, any questions?
We have time for one, guys.
So at the beginning of the presentation, you said that none of those were like technically dinosaurs, right?
Mm-hmm.
So what would be like by the book definition?
An actual definition of a dinosaur is they are terrestrial, and so think of like your creatures like a Triceratops, T-Rex, or Brachiosaur. Those are classified as a dinosaur. They are the most related to birds. They have a similar hip bone to birds, and that is what classifies them.
So what is like everything else called? Like dinosaurs?
Pterosaurs are called non-avian. They are called avian, and basically the ocean ones are obviously called aquatic, and then Dimetrodon is more related to mammals, like to us, rather than actual dinosaurs.
So like when people say dinosaurs, they say it as like a vague term instead of like an actual.
Yeah, when people say dinosaur, sometimes they are not actually referring to actual dinosaurs.
And just when people think dinosaurs, they think way back then.
Mm-hmm.
Yeah, cool.
And now up next is Brooke.